Hi guys, this is lesson 3 in unit 12. We're going to talk about scatter plot and its line of best fit. Let's start by trying to define what a scatter plot is. A scatter plot is a graphical representation to display numerical data with two variables. We use scatter plots to represent bivariate data. A scatter plot can be used to investigate whether or not there is a correlation between the bivariate data. A relationship between the two numerical variables or the two variables can be described as a positive correlation, a negative correlation, or there as no correlation between the two variables. When we do a scatter plot, we do not connect the points that we have. Let's take a look at our first example. We need to make a scatter plot for the following bivariate data. Looking at the table, I can see that we have study hours and region scores. And we're trying to find if there is a relationship between the number of hours that you study and the score that you get on your regions test. So I'm trying in this example to find out if the region score is affected by the number of hours that you study. So in this case, study hours is going to be the independent variable represented on the x-axis, and the region score is going to be the dependent variable represented on the y-axis. And to make a scatter plot, all I need to do basically is to graph the points that corresponds to both variables together. And looking at the scatter plot that we have here on the grid, we can see that as the study hours increase, the region scores increase as well, which means that we have a positive correlation between these two variables. Now we're going to learn how to make a scatter plot using the calculator. So the first thing we need to do is to hit the Start button to enter the data into the calculator, edit, and then put the first values for the first variable in L1. So I have previously entered data, so I'm going to change that into my new data. 3, 5, 2, then 6, 7, 1, 2, 7, 1, 7. And then I'm going to enter the second values, or the second set of values for the second variable in L2. 80, 90, and then I have 75, then 80, then 90, then 50, then 65, then 85, 40, and then 100. And to make a scatter plot, all I need to do now is to hit the second button, second, y equals, to get to the stat plot. I'm going to turn my first plot on by hitting enter, and then I need to make sure the on is highlighted, and then since I'm looking for a scatter plot, it's important to me to have the scatter plot simple highlighted, and then my X list is in L1, my Y list in L2. If you have the variables in different lists, all you need to do is to change these two values to wherever your list is. And then all I need to do now is to hit the zoom button 9 to see the graph in the stats window. And this is how we make a scatter plot using the calculator. Line of best fit. A line of best fit, or a trend line, is a straight line that best represents the bivariate data on a scatter plot. This line may pass through some of the points, none of the points, or all of the points. We can use the line of best fit to investigate the scatter plot and learn more about the relationship between the two variables. This line of best fit can be helpful when we're trying to interpolate or predict values within the given data. In this situation, we can use the equation of the line of best fit in our example to predict the region score for students who study for 4 hours, since we don't see 4 in the table. And we also can use the equation of the best or the line of best fit to extrapolate values outside of the given data. It's like trying to find out the region score that students can get if he studies for 10 hours, which is outside of the range that we have in this situation. Now, to find the equation of the line of best fit in your calculator, what you need to do is to make sure that you have your diagnostic on in your calculator. Go to Stats, and then go to Calc to calculate the equation of the line of best fit, which is number 4, and then hit Enter. Now, my X values, or my first variable on the L1 list, my second variable is on the L2 list. I don't have any frequency, so I'm leaving the frequency list blank. All I need to do now is to hit Enter to calculate. And then the equation is going to be y equals 6.273344652 x plus 49.77928693. Now, we're not expected to put all these numbers down unless there is no specification for rounding, but most likely you're going to be asked to round to the nearest hundredth or 10th. So in this situation, the equation is going to be 6.27 x plus 49.78 for rounding to the nearest hundredth. And now all I need to do to see that line of best fit along with the scatter plot, I need to go to y equals, put in the equation for the line of best fit, which is 6.27. I'm rounding to the nearest hundredth in this situation, x plus 49.78. And then I need to hit the zoom button, and then 9 to look at the scatter plot with the line of best fit together on the scatter plot. So if we look at this line, it does not go through all the points. it's the best line that can represent all of these data. So as you can see some of the points are above the line, other points are below the line. So this line basically is in the best place that can accommodate all these points. Again, correlation coefficient is the value that describes the accuracy of the regression in representing the data. The value of the correlation coefficient is equal to or between -1 and 1. The closer the correlation coefficient to 1 and -1, the more accurate the regression is. A value of 0 represents no correlation between the two variables. Looking at the correlation coefficient of our example, we can see that the correlation coefficient value is 0.85, which suggests a strong correlation, a strong positive correlation between the two variables.